Slideshow. So today I'll be talking about using catch-only models to assess the status of the data poor Baltic pike stock around the German island of Rügen. This work was performed at IGB Berlin as part of the Boddenhecht project. Kömle, Helmut Winkler, and of course Robert Arlinghaus. First, something about the study area. So for those who have been here on Tuesday, they'll already have heard all of this, I suppose. So we performed this study at the German Baltic coast at the island of Rügen. Now, this island is surrounded by many brackish water lagoons, which host both freshwater and marine fish species. Historically, it's also been a very important fishing area, especially for the Baltic herring. But northern pike also occurs in these lagoons, these bodden. And interestingly, there they seem to grow larger than in freshwater, with 1 to 1.2 meter pike being frequently caught there. And pike there is also, it's fished by both the commercial and recreational fisheries. With the commercial fishery, it's mainly a bycatch now. And for recreational fishers, probably because of their especially large size in these lagoons, it's an especially favored target species to catch there. Now, in recent times, reports have come in of people saying that the state of the stock there has been declining. And well, there's no active monitoring going on of the northern pike stock there. There's no management plan for it. And given especially its popularity among recreational anglers in recent times, it would therefore be important to start setting up a management plan this pike stock. So that was one of the goals of this Boddenhecht project. And for this, what we did is start with assessing the current state of the stock. Now, this was not as straightforward as it can usually be. Quite simply, there wasn't that much data available, not the data available you'd normally want for a data-rich assessment. So a lot of biological data was missing when we first started here. We didn't know if the stock was a mixed stock throughout all the boddens, or whether each separate bodden had its own kind of subpopulation. We didn't know how diadromous they were. Did they migrate between the freshwater rivers and the brackish water lagoons, or did they really stay in the brackish water lagoons? We didn't know. We didn't know about its age or size structure. Didn't know about its growth rate. Didn't know about its mortality. So that's not very good if you want to do a data-rich stock assessment. Furthermore, regarding exploitation data was also not as complete as we'd like it to be. In terms of fishing effort, what we knew regarding the commercial fishery is only the number of commercial vessels registered in the area per year. And when it comes to recreational effort, the only thing we knew was the number of angling licenses, whereas ideally you'd want, well, fishing effort in terms of either days fished or maybe even hours fished with number of gear used. And when it comes to removals, pretty much the only high quality data that we have were the commercial removals. We had a time series of commercial removals for bodden pike stretching back to the late 50s. And recreational removals, the only thing we had were 2 recent telephone diary studies being performed in the area estimated this. So in light of this data availability, what we decided to do is try and use catch-only models to assess the state of the stock. These are data poor models as data requirements. They have, most importantly, a time series of total removals for the stock. And often some need some additional life history information, and depending on the model, some other model-dependent information. And as an output, these catch-only models produce an estimate, a time series estimate of B over BMSY. So that is the biomass relative to the biomass that produces maximum sustainable yield. If it's above 1, you'd say that's good. If it's below 1, you'd say, well, in general, that's bad. So what data did we have available to put in this model? The removals data, so we had this commercial landings time series stretching all the way back to the late 50s. So that was good to have. we didn't really have any time series data for recreational removals, and seeing as how it's such a popular target species in recent years, you could guess that, especially in recent times, it's very important to have this information as well. So what we wanted to do about that is reconstruct a time series of recreational removals. For this, we firstly used two regional studies that I mentioned, which were performed in the area in 2006, 2007, and 2014, 2015. Those were telephone diary studies, estimating both the number of anglers and angling days for those years in the Rügen area, and as well the recreational pike catch and their harvest. So where catch is whether they catch it, in general, well, simply if they catch it, and when they caught pike, they can either harvest it or they can release it. Well, those studies also estimated harvest and therefore also release, because release is of course just catch minus harvest. Then by applying a release mortality, we took that from the literature, an average of around 8%. Based on that, we can have, for those years, quite simply an estimate of total recreational removals of pike from that area. And we used these two studies as kind of the anchor points between which we wanted to interpolate and outside of which we wanted to extrapolate recreational effort for the entire commercial catch time series as well. So for this, we used state level coastal angling licenses from 1991 to 2018 to kind of extrapolate this recreational effort over those years. And then using data from the East German Angling Association, the membership data, we extrapolated effort all the way back to 1954. And then we also had the number of commercial fishing vessels registered in the Rügen region as a time series of commercial effort. So now we have a time series of recreational effort and commercial effort. And then assuming a constant ratio of catch per unit effort between these commercial fishing and recreational angling, we were actually able to reconstruct a time series of recreational removals. That's quite, it was quite a complicated reconstruction process. So you can also read more about it in the paper that we published about this. You'll find a link to that at the end of the presentation. So what we found after reconstructing these recreational data, we saw a decline in commercial fishing removals over time, as you can see at the blue line here, and we saw an increase in recreational angler removals over time, as you can see at the red dotted line here. And now, in fact, we would estimate that recreational angler removals are the dominant source of pike fishing mortality in the area. So with that, we now have here in black the total removals time series which we can feed into these catch-only models. For this, we used 7 different catch-only models in R. The top 2 are what you would call empirical catch-only models. These models, they don't have any population dynamic models behind them. They simply take the removal time series that we feed them and compare that to removal time series of data-rich assessed stocks. And thereby they try to look for statistical correlations and give their best estimate of, based on that, what they would think is the state of the of the pike stock. And the bottom 5 models are where did they go? Well, the bottom 5 models are they're mechanistic catch-only models. So they have an underlying population dynamic model. That's usually a variant of the Shaver production model. And based on that and the catch time series that you feed them, they try to make an estimate of, well, what is B over BMSY bin in the past. And the result looks like this. Here on the right, you can see the 7 figures of the 7 different catch-only models predicting B over BMSY over time. And what you can see is that different catch-only models predict different values of B over BMSY, which, well, makes sense because different models, they work in different ways, they make different assumptions, and all indicate a recent decline in B over BMSY. That is quite interesting that no matter the model, they estimate its recent decline. Now, there's been a study recently performed about the accuracy of using catch-only models, and what they found was that by using catch-only models, they pretty much have a 40 to 60% inaccuracy, which, well, is not very great. And furthermore, most catch-only models have a negative bias, meaning that they estimate that the status is worse than it actually is, especially when the stock is lightly exploited. So what does that mean for these results that we've shown? Can we just take a mean out of this or just show it like this? Well, there's a better approach. What we can also do is combine all of these catch-only model results into an ensemble model. This was first described for these catch-only models by Anderson et al., and they termed it a super ensemble model, but that's quite of an exaggeration. It's pretty much just an ensemble model. And what this does is you then train statistical models first with simulated catch-only model results, and then having these trained models, you input your own catch-only model results. And by doing that, you hope that these trained models can then account for these individual model biases, that when under certain conditions, when certain models predict one thing, other models predict another thing, that by having these trained models, they can then say, well, under these conditions, we would give more weight to these model results and thereby improve the accuracy of your estimate. So how this works is, first of all, the goal of this ensemble model would be to estimate the mean and the slope of B over BMSY over the last 5 years. So you don't produce that entire time series, you just go for the mean and the slope of B over BMSY over the last 5 years. You simulate thousands of different catch time series for this, from species with, hypothetical species with different life histories, for different exploitation time series, and for different durations of exploitation. You simulate all these different time series. And then every catch-only model that we've used on this Pike stock, we also fit this to each simulated time series. Then for each of these results from those catch-only models, we take the mean of B over BMSY over the last 5 years and the slope over that time. And what we then do is we train these various statistical models with these simulated results. So for this, we used a linear model, a random forest model, and a boosted regression tree. So then the simulated results as the explanatory variables, the true result as the response variable, and then we get estimates of coefficients. Now we keep those coefficients, we input our own Pike catch-only model estimates, and use then we get an estimate of B over BMSY as the result. And yeah, the estimate of the mean and the slope of B over BMSY in the past 5 years. And what that looks like is like this. So here in black, you can see the estimates of the ensemble model, including their mean. And in the colors is the, abbreviated version of the catch-only model results. And what we see is that actually all of the different ensemble models agree very, very much with each other, which is quite, increases the confidence in that we've actually had it right. And they all show that currently we would estimate BMSY, we would estimate biomass to be below BMSY, and biomass is declining. Just to compare what would happen if we wouldn't include recreational removals, we'd get quite a different picture. Models would be much more pessimistic over time, and they wouldn't agree with each other as much either. So it's very important, that shows, to really include all of your removals in this test. So what can we then say? It's important to compensate for uncertainties of catch-only models if you use catch-only model results. You have to use multiple different catch-only models, and it's best to also include them in an ensemble model to kind of increase the accuracy of the result. And if possible, of course, you'd want to complement it by using other data poor assessment methods. In the next presentation, you'll see a different data poor assessment method being applied to this stock. But still, uncertainties will always remain. There will be data uncertainties. We don't know if the commercial landings are correct or not. We don't know if recreational catches have really been properly reconstructed. And the elephant in the room, what has been the environmental influence on the stock? Here, these models will assume that the environment has remained constant, but that might not be the case. So always uncertainties will remain, especially if we use data poor assessment methods. Lastly, of course, there's the point to discuss: would maximum sustainable yield be the best indicator to use here. So of course, recreational fishers, they care not only for, well, maximum yield, but they'll care for other things such as the experience or just catching pike. So to conclude, catch-only models can be used to get an indication of the status of a mixed-use data-poor fishery. It's important to include all relevant removals for this, use multiple catch-only models in an ensemble model approach. There's still considerable uncertainty, and these models are no replacement for more data-rich assessments. They're mainly a stepping stone that you can use to get some idea about the stock until you're able to collect more data for more data-rich assessments. And here you can see this article has been published in Fisheries Management and Ecology. So if you want to know more, you can have a look over there, or you can contact me via email or Twitter. And with that, I'd like to thank you for your time.
Thank you very much, Rob. I think this